All right, so the first thing you are to do is do numbers 1, 2, and 3, okay? There were proportions. This is something we did earlier in the year, and there are actually a couple of different ways you can solve these. If you look at number 1, you might notice that there's a relationship between the number 8 and 24. Raise your hand if you notice there's a relationship between the number 8 and 24. What is that relationship? Yeah. If I take 8 times 3, I get 24. Agree or disagree? Agree, right? So now, we know that when we're dealing with fractions and we're talking about equivalent fractions, we can do, as long as we're multiplying or dividing, right? We can do the same thing to the top and bottom to figure out what x is. So if I multiply by 3 on the bottom to get from 8 to 24, I can do the same on the top. So x must equal 9. Okay? That is one way to solve it. We also learned that if we can't see that relationship for whatever reason, that we can use cross multiplication. So what that looks like is this. We draw a big X in the middle, right? 8 and X are connected, so I write 8X. 3 and 24 are connected, so I would multiply. Someone who did it this way, what is 3 times 24?
72.
Okay, good. Oh, 72, I got ahead of myself. I was answering the question. Good. Then from here, we have to get rid of the 8, so we would use division to get x equals 9. Look, we came up with the same answer, okay? So if you cannot look at the fractions and just go, oh, that's times 3 here, times 3 there, then you could use cross multiplication. All right? So number 2, you want to cross multiply or you want to just look at the fractions? Look at the fractions. What is the relationship between 5 and 25?
5.
Times 5. Good. So 5 times 5 is 25. Do we all agree?
Yeah.
So we can do the same thing on the bottom. 7 times 5 is
35.
y equals 35. Very good. All right, the last one, I crossed out that bottom thing and I put a 9. How would we do that one? Okay, so 9 times 5 equals 45. Do we all agree? So 5 times 5 will give us t, which is 25. Okay? So that is what we're going to be using today. This is something we've already covered. We're going to use it in the context of shapes, though, or figures. So we are now moving on to our unit of geometry. The first couple of days of geometry, we've already covered in our proportions unit. We're just going to apply it with some shapes. It's going to be awesome, and you guys are going to be so successful at it, okay? So the question that I had you answer at the top of your paper was this. What are similar figures? Who came up with an answer for what are similar figures? What are similar figures?
The figures that need to have the same shape and size to be similar.
Okay, good. What else can we add to that? So we know figures equals shapes, right? We're good with that. Something to add? Anybody have anything to add? Okay, so figures are shapes. So we're talking about shapes that have the same shape but different sizes. Okay, same shape but different sizes. So in other words, if you look down here at these two rectangles, do you agree that they're the same shape? Yeah, they're both rectangles. Now, it can't just be, oh, two rectangles. The rectangles have to have what we call corresponding sides, okay? You have to find something that says that they are similar figures before you can just assume that they're similar figures. So it tells us here, find the length for each pair of similar figures. You may also see this. So you may see this little line here and a line there. That means that those two sides are similar. Okay, they match. You're also going to see, if you see that, you might see this, which means these two sides match or are similar. Okay, so there has to be something that says these shapes are similar. These are the corresponding sides. So we're going to use proportions to set up to figure out missing lengths. Okay, so here, what are we trying to find? We have a 4 inches, a 7.5 inches, a 3.2 inches, and an X. What do you think we're trying to find? What do you think we're trying to find? The X, right? So what we're going to do is set up a proportion. Okay, proportions look like two equal fractions. Everybody draw that on your paper. Fraction bar, equal sign, fraction bar. Okay? The important thing we have to do is match them up correctly. Question? Statement? Okay.
If you look at the side lines, you can subtract.
Nope, we can't do subtraction in these. We have to always be using multiplication division. Okay? All right, so what we're going to do is we're going to set up a proportion. Now, the most important thing, ladies and gentlemen, is you have to match the appropriate side lengths. Okay? So see how this is our shorter side? We need to match it with our shorter side. Okay? See how this is our longer side? We need to match it with our longer side. So we're going to use what we know to set up our first fraction, which is that 4 inches over 7.5 inches. That represents our first rectangle. Do we agree? Do we agree or disagree? Agree or disagree? 4 over 7.5. We good? Okay. Now, since we put 4 on top, which do you think we should put on top over here? The X or the 3.2? 3.2. And this should be our X. Okay? Now, can we just easily look at the relationship between 4 and 3.2 and see a multiplication or division problem? No. So this is where we need to use cross multiplication. Okay? So we're going to do 4x. I'm going to write it over here. Equals 3.2 times 7.5. Somebody with a calculator, do that math for me. 3.2 times 7.5.
22.
Sorry, do we agree? 3.2 times 7.5. Okay. So 4x equals 24. Questions about how we got that part? Okay, so we set up our proportion. We put 4 over 7.5, 3.2 over x, matching up the same length sides, so the shorter sides on top, longer sides on bottom. Then we're cross multiplying. Okay, 4 times x equals 4x, 3.2 times 7.5 equals 24. What do we do from here? We just need to get x. How do we get x? Divide by 4. Okay, on both sides. So what must x equal? 6. So that means this side right here is 6 inches. Okay, which makes sense, right? 7.5 is almost double 4. 6 is almost double 3.2. Okay. All right. Number 5, we're going to do half together, half on our own. Here we go. We have a lot of sides in this figure, and we have a lot of missing sides. So we need to start with 2 that we know that match up with something over here. Okay? So what two do we know on this figure? First of all, let's match them up. What does 8 match up with on here? Y. So let's just put 8 and Y go together. What does 10 match up with over here? 4. So let's do 10 and 4. What does X match up with over here? X match up with over here? 5. X and 5. And then what does 15 match up with? 15 and Z. Perfect. Okay? All right. So we've matched up our sides. Now let's set up a proportion. Let's use this one because we know 2 of them. So let's make sure we use 10 and 4. So let's put 10 on top and 4 on bottom. Or sorry, 10 on top. And let's find Y. So let's put 8 on bottom. That was my fault. Because we know both 10 and 8 in this shape, and we know 4 in this shape. Any questions why I picked 10 and 8? Because we know both of them, and we know their partners. Okay, so 10 on top, 8 on bottom. So what should I put on top in my other fraction? What should I put on top? What goes with 10? What goes with 10? 4. 10 goes with 4. We just wrote it right here. What goes with 8? What goes with 8? Y. All right, I'm going to pause and you're going to solve for Y. Ready, set, go.